Okay, today we're solving trig equations by factoring. So we will try to isolate variables, convert how we need to create little miniature equations and solve. Alright, so first here we need to get everything to one side. So I'm going to subtract the 2 cotangent x. That leaves me with cotangent of x times cosine squared x minus 2 cotangent x equal to 0. Then we say, well, is there a GCF? Is there something I can factor out? Well, it appears that I can factor out a cotangent x. When I factor it out, I'm left with cosine squared x minus 2 equal to 0. Now, this is a factor and that's a factor, and zero product property says that anything times 0 must equal 0. So either one or both of those are 0. So I set each one equal to 0. And then I solve. This one is, when is the cotangent value 0? Well, that's going to be when x over y is equal to 0. So I'll have 0 over some number. So that means I'll have a 0, comma, and then a number. And those two places would be at pi over 2 and 3 pi over 2. If we're just looking from 0 to 2 pi. Let's just say 0 to 2 pi here. Okay, and then here I would add 2. I would say the cosine squared of x is equal to the square root of 2. And the square root of 2 is actually 1 point something. So when I find the cosine of some angle being plus or minus the square root of 2, it's actually not possible. Not possible. So my only two solutions here would be pi over 2 and 3 pi over 2. If I wanted to write them as equations, it would be x equals pi over 2. Well, we don't necessarily have to get into all that just yet. So let's just keep it between 0 and 2 pi for now. And those are my solutions, pi over 2 and 3 pi over 2. Basically what happens is when I go back up here and I plug in a pi over 2 and a 3 pi over 2, that makes this factor 0, and 0 times anything is 0. That makes this factor 0, and so 0 times anything is 0. And you have 0 minus 0 equals 0. All right, let's look at the next one. I'm going to subtract 2 sine of x. I'm going to bring everything to one side. Sine squared x minus 2 sine x is equal to 0. I can factor out a sine of x, and I'm left with sine of x minus 2 is equal to 0. So I have my two factors. This one is sine of x is equal to 0, and this is sine of x minus 2 is equal to 0. This would be the sine of x is equal to 2, which we know is not possible. Remember, it has to be less than 1 and greater than negative 1, and this is not going to work. All right, so what values is sine 0? Well, that's going to be at 0 and pi, and those are my solutions. Okay, the next one here, I'm going to bring everything to one side, so I have 2 cosine squared x minus 3 cosine x equals 0. I'm going to factor out a cosine of x, and that leaves me with 2 cosine x minus 3 equal to 0. Again, I set each factor equal to 0. I have cosine of x is equal to 0. Then I have 2 cosine of x minus 3 equals 0. When is the cosine of x 0? That's at pi over 2 and 3 pi over 2. Then I add 3. 2 cosine of x equals 3. Divide by 2. Well, now that's not going to work, is it? Because 3/2 is still greater than 1, so this is not possible. Okay, so my two solutions are pi over 2 and 3 pi over 2. Okay, that's kind of using a GCF, the greatest common factor. Now let's talk about factoring algebraically. Again, we're still in the interval 0 to 2 pi here. So 2 sine squared x minus sine of x minus 1 equals 0. So it's actually already in standard form, and that would be almost like a 2x squared minus an x minus a 1. When I go through and I factor, I get a -2, factors of -2 would be -2 and 1, divide by the liter, and that's a -1 over 1 and a 1/2. So that will be 2x plus 1 and x minus 1. So over here I go back and substitute. I have 2 sine of x plus 1, and I have sine of x minus 1 equals 0. Then I set each of these equations equal to 0. Okay, subtract 1. Then divide by 2, and so sine of x is equal to a -1/2. Well, I am very much aware that that is a value on our unit circle. So when is the sine value -1/2? That's going to be at 7 pi over 6 and 11 pi over 6. Okay, this one I add 1, I end up with the sine of x equal to 1. When is the sine of x equal to 1? At pi over 2. So here are my three solutions. Okay, the next one, 2 sine x squared minus 3 sine x plus 1. That's like a 2x squared minus a 3x plus a 1 equal to 0. Alright, so I have a 2 times a 1 is a 2, factors of positive 2 that add to give me -3. -2, -1. Divide by the liter, that's a -1 over 1 and a -1/2. So this will be a 2x minus 1 and an x minus 1 equals 0. So here I have a 2 sine of x minus 1 times a sine of x minus 1 equals 0. Set each one equal to 0. I would add 1, divide by 2. This will give me a sine of x equal to a positive 1/2. Add 1. This gives me a sine of x equal to 1. When is the sine of x equal to 1/2? That's going to be at pi over 6 and 5 pi over 6. When is the sine of x equal to positive 1? That's at pi over 2. So here are my three solutions between 0 and 2 pi. Okay, here's another 2 cosine squared x minus 5 cosine x plus 2 is like a 2x squared minus a 5x plus 2 equals 0. So I have a 2 times a 2 is a 4. Factors of positive 4 that add to give me -5. That's a -4 and a -1. Divide by the liter. That's a -2 over 1 and a -1 over 2. So that will be x minus 2 and 2x minus 1. equals 0. Okay, so that's going to be a cosine of x minus 2 times a 2 cosine of x minus 1 equals 0. Set each factor equal to 0. This is a cosine of x equal to a 2, which is not possible. And this is a cosine of x equal to a positive 1/2. When is cosine equal to a positive 1/2? That's right here at pi over 3 and 5 pi over 3. So that one only has 2 solutions within that interval. Okay, just to clarify, right here for this equation, it is a sine of x, so if I did want to write all possible solutions here, it would be a 0 plus 2n pi. This would be a pi plus 2n pi, where n is an element of the integers. Okay, so I'm just going to look at what that last equation is. This one right here is a cotangent, so that would be an x equals pi over 2 plus just an n pi, and this would be x equals 3 pi over 2. Well, that takes care of this one right here, so I don't even need to put that, just nose here. So if I did have to write an equation, I could still do that. Cosine, again, the natural period is 2 pi. So I would have x equals pi over 2 plus 2n pi, and x equals 3 pi over 2 plus 2n pi, such that n is an element of the integers. And yes, I could actually combine those and say that x is equal to pi over 2 plus n pi, where n is an integer. Okay, I could combine those. I could also combine these here and say that x is equal to an n pi, such that n is an element of the integers. So again, if you need to keep them separate, you're welcome to do so. If you need to combine them, you can do those too.